Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of laws of exponents. This is standard A.11B in the great state of Texas, and we are using item number 26 of the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find an expression that's equivalent to all of this. X and y are defined. That means they can't be 0. Because if x or y are 0, they end up in the numerator or the denominator of a fraction, right? You divide by 0, that's undefined. So that's all that means. So before we even split this up into like terms, first thing we're going to need to deal with is that bottom expression, because I'm taking the 3 to the x to the y and then I'm squaring it, right? So what do we do with that? Well, if I take my 3xy and I square it, I don't have any exponents within there, right? The x and the y don't have any exponents other than like an invisible one. That's not going to do anything. So probably the simplest thing for me to do here is I'm going to distribute out that squared into each of these three terms separately. 3x, y. And you could just end up squaring each of them separately. It's the same as if you took everything together and just kind of factored out that squared, put them all together. So 3 squared, right? That's just going to make 9. X squared obviously just makes x squared, and then y squared makes y squared. So what we need to do now is we need to rewrite this as 36, and spread it out a little bit. X to the 4th, y to the 5th, over 9, x squared, and then y squared. The reason I want to do that is because I want to now deal with each of these expressions individually because they have the same base, or they're the same type. Because this 36 over 9, right, that's just two coefficients. So 36 divided by 9 is, boom, it's 4. So we get that. So if you were to take the 36 and have it over x squared, you can't do anything with it because they're not like terms. But if you just take two integers, 36 and 9, those are like terms, and divide them, you get 4. Okay, so we get this x to the 4th over x squared, y to the 5th over y squared. Okay, both of those are going to require us to do the same thing. And so if we were to look at our mathematics chart or reference materials, we are going to see something that looks like this. We have to be able to recognize which of these laws of exponents we need. Quotient of powers. Okay, so the example they give us here is if you have one term there and it's divided by another term. Now here's the key, is both of these have the same base. Okay, so the base is that big number. In this case, it's an a. You have to have the same base for this to work. If it's a to the m over b to the n, you're not going to be able to do anything. So the same base, what that means is you can take that base, a, and simply subtract your two exponents. So that's the trick there, is when you have a to the m over a to the n, keep the base, subtract the two exponents. We'll take a look over here. I've got the same base. I've got x and x. So I'm going to keep that x, and I'm simply going to subtract those two exponents. I can do the same thing here with these y's. That's why I spread them out and look at them individually. Same base. And I'm simply going to subtract my two exponents, the 5 minus 2. Okay, so now we just need to simplify this, make this look a little bit cleaner. So I've got my 4, and obviously, I mean, once we figure out that this is 4, there's only one option, so that's helpful. But I've got my x, and then 4 minus 2 is going to be to the 2, or x squared. And then y, and then 5 minus 2 is going to be 3. So my answer here is going to be h.